All right. Video, I don't know what is this, 3 or 4 in this marathon. I'm doing these all back to back. So take a drink break and a bathroom break and then come back in. So I'm at a little over 2.5 hours now. So hopefully you're not watching these all back to back. We left off talking about layer 3, and I made a couple changes, added a couple things. I did add frame for layer 2, packet for layer 3, and segment for layer 4. Although, as I said, in this class, for the most part, we talk about packets and frames being the same thing, and we usually don't bring up segments. But you know, for what it's worth, they are different things. And in TCP/IP class, I'll start splitting hairs, but in this class, essentially frames and packets. I'll try to be clear about what we're talking about, but generally, you know, if you were talking about in class and you'd said something about a packet and we're talking about layer 2, I'm probably not going to correct you and say, well, you know, technically it's a frame. In TCP/IP, hopefully I'll be more anal retentive about that. A couple other things, I added TCP/IP to layer 4 and 3. We can see there's layer 4, TCP/IP layer 4 and IP at 3, SPX, IPX, and NetBEUI. We had talked about that already. I just transferred it onto this sheet. We had talked earlier about being connectionless. Layer 3 and all of the things that go on layer 3 are connectionless. Connectionless means they don't care whether it gets there or not. So layer 3 is responsible for making sure that the address gets on the package and then it gets out the door. That's it. That's the end of the responsibility for layer 3. What happens if it dies on the way? Don't care. What happens if... Don't care. All it's responsible for is making sure that it has a network address that is valid at the time that it's going out the door and that it left. So when we're talking about things that are quick, you know, we've already talked about lowering the stack is faster, but in this case, everything that's happening at layer 3 is going to be connectionless. Now, I've got another stupid addition to this. I had this little mini chart right here of TCP/IP, IPX, SPX, and NetBEUI. For some reason, I had trouble early on keeping track of what goes at what layer. And then when we got connectionless and connection oriented, because TCP, SPX, and NetBEUI are connection oriented. So because this layer is a connection oriented layer, and almost everything at layer 4 is connection oriented. There is one big exception that we're going to come up on. For some reason my nose is running, sorry. Didn't mean to sniff there so that you got the whole benefit of that, but I apologize. So we had connectionless. Connectionless was down here, and connection oriented is at layer 4. So generally speaking, 3 is connectionless and 4 is connection oriented, because this is get an address on and get it out the door, and then layer 4 is all about making sure that it gets there, because we had error checking missing. If it doesn't get delivered properly, then layer 4 is actually going to be responsible for connecting to the transport layer on the other end and say, hey, we didn't get it, can you send us another copy of it? So anyway, I had trouble with that, and through connectionless and connection oriented in, and I was trying to figure out how I can do it. So I came up with a phrase that all of these protocols are blind, because the I's, IP and IPX, can't see, meaning because they can't see, they are connectionless, which means that the things that are not IP and IPX, the things that are TCP, SPX, and NetBEUI, are not connectionless, they are connection oriented. So protocols are, it's taking me way too long to write out. Should not have done it. Protocols are blind because the eyes can't see. Anyway, that's the things that I come up with, these stupid phrases like all people say that nerds dress poorly. Those are mnemonics or things that you can remember easily. And when we talk about being in a certification scenario, if you haven't taken a certification, especially if you haven't been under pressure taking a certification, it's the first certification, question one could have been, are you warm-blooded? Question two could have been, do you live, where do you live? Do you live in a house? Do you live in a cardboard box? Do you live in, and I mean, both of those questions I would have been like, oh my God, I don't know. I left this morning. I woke up. Was I in a box? I don't remember. There's so much going on that you're just completely overwhelmed by it. And even the easiest questions tend to be really, really difficult. One other thing that happens, and I know the CCNA that I took, Cisco's CCNA certification, the 10 hardest questions on the entire test, and it was adaptive. So you got question one, and then when you answered question one, it told you basically whether you got question one right or not in question two, and then three did the same thing. But anyway, the 10 hardest questions were the first 10. So I've had a couple different certs that actually stack that way, that you get to question 10, and on the CCNA, I basically know going in how many questions there are, how many questions I can miss, and I'm kind of doing the math from question to question as we go. I got in 10 questions, and I knew I think I'd missed 8 of them at that point. So I've missed 80% of the questions, and then I got to question 11, and question 11 actually was, what OSI layer does a hub work at? Yes. We finally got to an easy one. And then after that, I blew it away and I passed. Thank God I passed. But the 10 nastiest questions were the first 10 questions. And that I don't know if it's intended that way to be unnerving, but it does. And, it's that environment makes it so that I want to have these stupid things that, all people say that nerds dress poorly or whatever else, things that I can come up with that I don't have to think deeply about, that I can fall back on, and I know that I've gotten it right. So anyway, you will continue to, and the whole, all of these mechanisms really are geared toward this certification environment. So, do they work for test taking? Yes, they do. But I think personally, I take tests very well. I don't get too worked up about it. I've taken the ACT and the SAT and the GMAT and, whatever. I don't get really, really worked up. But certification, when there's that much money, usually there's $150 to $300 on the line. If you fail it, you flush that money away. And again, I was in a unusual pressure situation where I kind of had to pass. And I haven't failed one yet. So now I'm like 30 some certifications in, and I haven't, well, I take that back. I did break that streak, I guess. It wasn't an official mainstream certification, but the Microsoft Office Specialist Excel Expert 2 test, I did fail by 10 points, I think. But it was I wasn't expecting to pass it when I took it, so it wasn't that bad. I wasn't crushed by it. But all of my CompTIA and Cisco certifications and all my core Microsoft certifications I passed. So, I mean, as we got further on, there's more pressure. And I'm the instructor, so, if I go for the certifications, there's the assumption that I'm going to pass. So, I'm trying to come up with every trick in the book that I can use legally to get in and pass these tests. Now, one of the things that we'll talk about is brain dump before we're all done, and that is coming up with something kind of like this. And I wouldn't actually create this, but a shortened version of this, if you're taking the Net Plus, where you can, anything that you're confused about, you can write out like this. And then when you get a question about what layer does, oh, hey, we talked about pivot questions early on. Let's talk about a pivot question here. So if we came up with a pivot question, is when we have two topics that we have not talked about before in relationship to each other. So I guess we did talk about topologies and bridges, but let's come up with flow control or error correction. The frame check sequence, is it the same as a topology? So we might have a question that has something to do with topologies. Which of the following has to do with which of the following could be knowledgeable about or could see frame check sequence, and it would have a list of things. It'd be TCP, IP, Ethernet. Ethernet would operate at that, or we could have Star Ethernet or Token Ring or something like that. That is a topology. That is at layer 2. So is the frame check sequence. So they're at the same, and they can see each other. And those all of these things actually work into certification. So that's kind of the driving force, which is really the annoyance on this going online. I know our administration thinks this is completely fine and it's just as good as teaching in the classroom. I don't think so, but I mean, that part's neither here nor there. There are some advantages of this because you can watch it over and over, and you can pause and you can back up. And at midterm, you could watch the entire thing again, and there would be some benefits to that, as opposed to in the class when it's gone and you'd miss out. You don't, if you're sick for a day, you don't miss out. You can do this. So I mean, there are some advantages of this, but the certification prep component of this that I'm missing out, where I would say, which layer does this operate at? You can look it up. You're going to need to know that for the Net Plus. You're actually going to need to know all these things off the top of your head. So one of the things that we will do when we get done with this, and I haven't created it yet, but there will be you're going to have to build this table. I want you to take a blank sheet of paper and put as many things on there, and then check your notes, and then add, and check your notes and add. You should be able to come up with, well, I mean, I've added junk at the top, but you should be able to come up with all of this content and put it in the right location before we're all done. So all of this should be pretty familiar to you, and you know where it lands and why it's there. Okay. All that, I'm 12 minutes in, and I was supposed to be doing layer 4. Okay, so we added the extra pieces to layer 3, and I've added the connection-oriented portion for layer 4. If we go down to the screen and the transport layer, we know we get flow control already because we already talked about that. Multiplexing is a minor thing. Multiplexing is the ability to have, it would be, and I just did this. I had 2 separate Amazon orders, and they came in the same box. That's multiplexing. So we would have physical multiplexing, which is like your DSL or cable modem, which actually takes maybe television and phone and internet and multiplexes them together and sends them across. And then your modem, your modulator, demodulator. That's what a modem stands for. So it demodulates. It takes this multiplexing and demuxes or demultiplexes it into your 3 channels. And on the back side of that modem, you got one line coming in, which is your phone line typically. And then you'll have a line going for TV, and then going for internet, and going for your phones. So that is one type of multiplexing. So that's physical multiplexing. And data or logical multiplexing is having 2 different, let's assume that we have, I have one connection to my, to a server because I'm looking at a website, and I have the same another connection to that same server because I'm accessing a file on it. It's a file server as well. So it's a web server and a file server. Multiplexing in that case would be taking data from each of those connections and actually putting them into the same packet. In this case, it would be segment because we're at layer 4, but into the same data packet and sending it. So I would have to know when I'm bringing it back out, what's it go to. So 2 different conversations going and coming to me at the same time, and then being split out. So they're both coming from the same address. They're just having to do with 2 different conversations. Now, that brings up one of the things. We had the MAC address at layer 2, and we had the IP address at layer 3, and now, black pen, now we have a port number. The port number in layer 4 is the logical address of the service connection communication. It's kind of the phone number for the function that we have going. So I would have one port number, probably port 80 or port 443, going for my website connection, and then I'd probably have an upper level port or a ephemeral port going for my file server connection, because it's not a well-known port. There are 65,536 total ports. The bottom 1,024 are called well-known ports, and we'll talk about well-known ports a lot more later. But when I have a conversation with someone else, that conversation is going to have the MAC address of the sender and receiver. It's going to have the IP address of the sender and receiver, and it's going to have the port number of, or the service number of the conversation that I actually have. So every individual service running is going to have different port numbers going to it. And I go back here, and we used netstat before. We're going to get back to all of these tools later when we talk about IP. But netstat actually shows me the IP address that I'm communicating with. This is my loopback address, and this is my address. So this is my local address, and then this is the external address. Hang on. Let me do that. I thought it was, nope. Yep, N. I thought it was D, but it's N. All right. So let's do -N numerical. The other one's D. All right. So this is showing me internally, this is my address and the port number. These are upper level port numbers that I'm using. And on the other end, so there's 443 is HTTPS, so that's secure HTTP. So those are all web connections. So that must be all the connections that I'm having from this page here. So there are a lot of connections there. Actually, I'm using two different desktops, so this would be all the stuff on the other desktop as well. So this is the IP address, colon, and then the port number. So this is showing me I'm talking to this server, 172.217.214.189, and I have an HTTPS connection, and it's currently established. I'm also talking to this, but this is at an upper level port, so that's doing something other than a web pull. It could be some other data transaction, could be it's on the internet, so I don't know what it is. But these are all the connections that I currently have, and they're all based on layer 3 and layer 4. They're IP address and port number. And there's always a colon in between. IP is always first, there's a colon, and then there's a port number after that. And it said if it's less than 1023 or less, it's a well-known port, which means it actually has a defined number. And actually, let's do this. Microphone is so big I have to look around it. All right, if we look down, there's Wikipedia I could go to. Oh, look, IANA. Do you remember IANA? If we go all the way back to the beginning of this chapter. Whoops. IANA. There we go. Internet Assigned Numbers Authority kept records of reserved IP addresses. They actually set up well-known ports as well. So if I go back here, you can see how old this is. It's all ASCII text. So let's go to 443. Got to go quite a ways. Whoop, just barely. Okay, so then I need 8. All right. So 443 shows me that I have HTTP protocol over TSL SSL, which is secure HTTP or HTTPS, and it shows that I have 2 different ones here. Let me blow this up just a little bit. Wow. Okay, so 443. There we go. All right. So I've got HTTPS or secure HTTP is port 443, and I've got, oh, look at this. There's a TCP version and there's a UDP version. Now, all these have a TCP and a UDP, TCP, UDP, TCP. So all the way through, we've already talked about TCP, Transmission Control Protocol. Internet Protocol was the IP part. You probably should know TCP is Transmission Control Protocol, but yeah. UDP is User Datagram Protocol. Now, I'm going to go back to, and I'll write that out. Okay, hang on. I can only do one thing at a time. UDP, User Datagram Protocol. Transmission Control Protocol, Internet Protocol was TCP IP too. I'm not going to write that out, but UDP, User Datagram Protocol, actually is at layer 4. So we had TCP and we had UDP, and UDP is special. So it is an exception. We already talked about layer 4, the TCP, or the transmission, sorry, let me start over. We talked about connection-oriented being layer 4, the transport layer. So everything at layer 4 is connection-oriented with one exception. That one exception is UDP. So User Datagram Protocol is a connectionless protocol operating at a connection-oriented layer. Now, the question is why? Well, we go back to this, and this is why. So if we're transporting data, data is really important and it has to all get there. So if I'm downloading a file, I definitely want the file to get there, and I want it to get to me successfully. I want 100% of the data to get to me. And if anything ever happens, I lose a packet, let's say there were 1,000 packets and I lost 5 of them, it's really important to retransmit those later. I need to be able to make sure that I get that. But there are some scenarios where I don't want that. So if I'm streaming, if I'm doing a voice over IP connection, I'm doing a Skype call or something like that, I don't want to have, if I'm doing a Skype call let's say I'm streaming this, and I drop a couple frames, I don't want those frames sent 5 to 10 seconds later. Then they'll be out of order. So when we're doing audio or video streaming, if it gets there on time, that's great. But if it doesn't get there on time, we don't want it. We don't want error correction. We don't want to make it up. So we do best delivery possible, essentially, for streaming. So if it can get there on time, it's great. And I used to work at a TV station a long time ago, and we had what was known as a TBC, a time-based corrector. And a time-based corrector has a frame grabber in it, and it's specifically for that. So if I'm getting packet 1, 2, 3, 4, 5, what it does is it grabs the packet and it holds it kind of in a freeze frame. So if I don't get 6, 7, 8, or 9, it's still holding on. That TBC is still holding frame 5 on the screen, and then it gets the next available frame and it goes to that. So that time-based corrector was always frame grabbing whatever the last frame was and holding on that. And you wouldn't want that lost frame to come in. That lost frame to come in and be made up later. And in a streaming sense, it's the exact same thing. I don't want to drop a packet and then have it later, because it would be all garbled, and especially the video would be all glitchy. And you've seen it where you're on a Skype call, you're on some other voice over IP, and it'll do that. And that's actually better than actually having the correction come later and it all be out of order. So we would much rather it, if it can get there on time, great. If it can't get there on time, just drop it. And that's actually connectionless, and that's what UDP does. So UDP is used in an environment where I need real-time delivery, and I don't want to have a connection-oriented delivery where I'm going to make it up. So if it's streaming, we're going to use UDP. So if it's audio or video or streaming, or if it's something else where, you're watching a Netflix movie, is going to be streaming, anything like that. If you're using data connections, then I want connection oriented. We're going to use TCP. So it is the exception to the rule, but without this exception, we would not be able to do streaming audio or video. And early on, we didn't have streaming as an option. And so, this was kind of a patch. I mean, it was really, really early on, but this was a patch after the fact. And that's why it's weird that everything here is connection oriented except for this, which is connectionless. Okay. And that explains UDP, User Datagram Protocol. And it's really the big exception that we have. Most of the other things are pretty standard, and they obey the rules fairly well. Okay, so we had flow control, we had error checking. We already talked about that. I'm checking my list of other things that we had. We still had frame ordering, just like we had down in the data link layer. When we get things, we put them in the right order. Frame ordering. We also hold on to everything. This error checking, it holds on to everything until everything has been received, and then it passes it up. We talked about the MTU, which is the maximum transmission unit. Transmission unit. The largest packet that we can have on the network, and still be able to put it through. If not, it will fragment that. It will break it up into sub pieces and send it on. And that we looked in Wireshark, and that don't fragment bit said don't do that. If it doesn't make it through and the MTU is smaller than that, just drop this packet. And sometimes that becomes a problem. We've got a couple other things that happen. We actually have a three-way handshake. Which is way over on the edge. Okay. I'm going to go back to here, and we're going to talk about the transport layer. Okay, so right here, some transport layer protocols take steps to ensure that data arrives exactly as it was sent. I mean, we have at layer 2, we have the frame check sequence done by the CRC, the cyclical redundancy check. Here it talks about connection oriented. They establish a connection, and it's called the three-way handshake because it starts with a synchronization packet. Hey, I'd like to talk to you. Then the remote machine responds with, okay, I'm okay with you talking to me. And then I respond with an ACK. There's also a negative acknowledgement, an ACK that I could have, but usually it'll be an ACK. So my initialization is a synchronization acknowledgement, and then a final acknowledgement. And if we go back to Wireshark, remember we used Wireshark before, we should be able to scan through here. I did not plan this ahead of time, but I should be able to plan. Okay, so there's an ACK. We actually have a few other, there's some push ACKs. There's a SYN ACK. We should be able to get a SYN in here somewhere. If I there's gratuitous ARP, those are fun. That's pretty rare. We won't talk about that until we get to TCP/IP, but that is a fun thing to talk about. When I initialize a connection, you're probably seeing, I could actually filter for this, but okay, there's a SYN packet. All right. So, hey, I'd like to talk. There's a SYN ACK. There's an ACK. Are these all the same? This is me, 192.168.1.185, talking to 179. I'm just going to use the last octet. 185 talking to 179. I would like to establish a conversation. 179 says, okay, fine with me. And my machine 185 says, great. And now we have we had another push ACK after that. But this SYN ACK, that is a three-way handshake right there. And at that point, we are established. At this point that we have the ACK, this 179, I actually could go here, and I should be able to have, was that 192? 192.168.179. So 192.168.179 should be in this list. Let me up arrow. I have an established connection. Well, this was a long time ago too. I guess I'm looking at my currently established connections as opposed to this. Can I see what kind of packet this was? 179. I got to come down to here. There's an ACK, another ACK, and a push, and a push. These are all push ACKs. Oh, that might be. I got a Raspberry Pi that I'm actually connected to. That might be my Raspberry Pi. Let's see what's going on. It's a TCP packet, so it's a data packet. I'm actually sending that's actually the data that's being sent. Source port is 60,000, so it's an upper level port on both. I can't really tell just by looking at this what it is, but nope, my Raspberry Pi is off, so it's not my Raspberry Pi. I don't know what it is. My machine is communicating with something on my network. I'm trying to look at what else I'm connected to. I don't know what else I have that has an IP address I'm connected to. Might be a printer. Could be a printer. Yeah. Could be. It keeps updating. But on these, we're seeing ports here. We're seeing these. Oh, by the way, this has an ACK to it, an acknowledgement, which is a transport layer. So it's definitely going to have, there's the frame and Ethernet 2. This is the frame type. So those are both layer 2, layer 3, layer 4. And then we come down and it'll show right there's my flag, my ACK flag, which again, TCP IP class will break that out. So this is actually hexadecimal too. And we can see there's my ACK, there's my SYN. A SYN ACK would be a 1 here and a 1 there. Oops. Can we get a SYN ACK? There's a push ACK. There's a SYN ACK. All right. You don't care about this. I know you don't care about this, but there's the SYN is set and ACK is set. So I get a 1 and a 1. And so it's actually binary that adds up there. So 1, 2, 4, 8. Whoops, 0, 1, no, 2, 4, 8. How did that work? Oh, yeah, sorry. Okay. This is binary. 1, 2, 4, 8, 16. So this is actually 16 plus 2 or 18. This is hexadecimal. So the 1 is 16 plus 2 is 18. So that it actually is 18. In hex, which shows me that I've got both my ACK and my SYN, so that this is a SYN ACK. Sorry about that. It's been almost a year since I went through there and taught that class. So anyway, you're seeing all the, there's a FIN ACK. A FIN packet gets sent when I'm done. So I'll send a FIN out, and then there'll be a FIN ACK that basically it's like, okay, goodbye, and then goodbye is the FIN ACK coming back. So this is, where did those FIN ACKs go? That is coming from me to, so the 179 said, okay, I guess we're done then. And I said, okay, goodbye. Yep, there's the FIN ACK and then the response back. So that is, I'm hanging up, and that happens at layer 4. Because that's part of the three-way handshake and closing out, but then it would be the session layer that would come in and would actually terminate that connection after that happened. So we get to see all these things and how they start to actually chain together is kind of cool. Okay, we talked about the MTU and the maximum transmission unit. Usually 1,500 bytes is the maximum that we could possibly do. If it's larger than that, it actually does segmentation and breaks it down. As I said, at this layer, we actually have segments. So we get segmentation. I guess I could add that here. Technically, the breaking it up into smaller parts. So that was what the president's assistant did when we had the 10 pages and we can only put 5 in. We did segmentation and broke it up so that it was envelope 1 of 2 and 2 of 2. And that was based on the maximum transmission unit that they had at that point. If the MTU is set incorrectly in the operating system, When it gets down to the data link layer and the NIC actually has to put it on the wire, it'll have to repacket it. It'll have to break it up and then redo the assembly, which takes time. Coincidentally, Windows 95, when it was first released, Windows 95A had an MTU set incorrectly. And so I can remember when 95 first came out, you could go in and you could do a registry hack that would actually change the MTU, and you could increase your internet speed by like 10%. It wasn't a lot, but it actually did make it faster because every packet that was, every segment that was coming through was actually being bundled too large. And when it got down to the data link layer, it had to be unpacked and then repacked and sent out. And that took time. By fixing the MTU so it was actually packed correctly at the beginning, it actually went there. Now, at the time, I had no concept of what the MTU was or why or how that was happening or why it happened or why it was better to have the MTU changed. I understand it now, which is kind of cool. But at the time, I just know that it made the internet, it made my download speeds or my communication actually better. And it was actually only outbound, things going outbound. It didn't have anything to do with things coming inbound because they would have already had an MTU that was right. Hang on. There's segments and segmentation and MTU and reassembly and sequencing, putting things in the right order. So we've talked about all those things. There's a long message that's broken up and sent. Oh, look at that. Looky there. We just looked at that. Well, I mean, we looked at all the flags because I opened it up. But, you know, this was stuff that early on when I taught Net Essentials would just be like, oh, well, that's way more technical than what we need. But we actually looked in Wireshark and went through all that. So that's, I think that's pretty cool that we can do that. Fragmentation. Oh, that was layer. They're talking about layer 3 there. All right. So, yeah, we already did. This is weird because I'm going backwards through this. So the book started at layer 7 and actually is walking back through. Okay. Let's go back to this and review what we've got. Okay, so the three-way handshake was SYN, ACK. I mean, there were a few others. We had PushAC and FinAC, but for the three-way handshake is actually those three: SYN, ACK, and ACK. So synchronization packet, synchronization acknowledgement, and then an acknowledgement. Now we could also have a NAC, a negative acknowledgement. If we said no, sorry, I don't want to. You don't see those very often, and obviously we didn't see any in there. And the other things that were in the flagged list we'll actually talk about specifically, and I'll show you in IP class. I actually do packet captures that actually show that, so it's kind of cool because you get them in Hexadecimal. You got to figure out what they are and what the options are. So this three-way handshake is part of the connection-oriented environment here. So we know that, hey, I'd like to talk to you. Okay, I'm available to talk. Good. And now we're connected, and now we have our conversation at a port number because that conversation actually has an identifier there as a port number. And when we're done, we would fin and FinAC, and we would disconnect that that connection. So it all kind of fits together. I like how it all kind of comes together at the end, and you see, oh, okay. So we're through this. I realistically have one more kind of, actually, no, let's just do it now. Okay, so 5, 6, and 7. I'm not even gonna draw 5, 6, and 7 out here because 5 is the session layer, and that is creates, maintains, and terminates connections between machines. Actually, I guess we do need to do the presentation layer, so let me do. So 5 session creates, maintains, and terminates connections between machines. The way I'm sitting is weird. I'm sorry. In order to write, I have to go sideways. 6 is the presentation. Presentation is all about formatting. So it has to do with the file. Whoa. Another right. It has to do with the file format that we have. It has to do with compression settings that we have, and encryption and file format. So if I change something from a DOC to a PDF, that would be a presentation layer function. I compress or encrypt it, or decompress or decrypt it, that would be a presentation layer function. And then layer 7, the application, is all about I/O. We said APIs, application programming interfaces, anything in the operating system that's set up to be used externally by a developer to actually do calls, and any dialog boxes generally are going to be application layer. So file open, file save as, file print, or any informational things coming up, generally anything like that in IO is going to be an application layer function. Let's go to the book. And I mean, like, the transport layer is really, really long, and the data link layer and application, application layer, we talked about APIs there. Most of the HTTP and FTP and SMTP, Simple Mail Transfer Protocol, and SNMP, Simple Network Management Protocol, are all vertical, so they all stack vertically across. If we go back to here, all of those types of protocols, all stack vertically across all three of those generally. So in a lot of ways, 5, 6, and 7 are actually looked at as one block, because they all kind of work the same way. So there's application layer. There's not a whole lot there. And then presentation layer. Presentation layer talks about formatting there. So there's 2 paragraphs on that. Session layer actually is a lot longer than I would think it would be, because the definition is pretty short and sweet. And then, transport layer is multiple pages? Yeah. Transport layer is 3 pages, and the network layer is 3 pages, and the data link layer is like 5 pages. Okay. Hey, look at this. Session layer establishes, maintains, and terminates user connections. Presentation, using a common language, data formatting, encryption, and compression. Provides interfaces between software and the network. Those are all ones we just did. Ensures accurate delivery of data through flow control, segmentation, reassembly, error correction, and acknowledgement. Oh my God, that's exactly what we talked about. Establishes network connections, translates addresses into their physical counterparts, and determines routing. I'm not a big fan of that one. That translates network addresses into their physical counterparts kind of leans toward MAC addresses. So I would stay away from that definition. Packages data in frames appropriate for the network transmission. Yeah, and I would probably put physical address. I'd use logical here and physical here to get IP and MAC there, but I mean, I didn't write this, so. I did get, this has nothing to do with anything, but I did get to be an editor on the Server 2019 book that's getting ready to come out. I think it's going to come out next month. So I'll actually have my name in a textbook. That's kind of cool. These are the 802. This is the 802 model. The 802 number, I believe, comes from, it was developed in February, the 2nd month of 1980. So 2 is month and 80 is year. And it is a definition of different ways of communicating. So we have Ethernet there is 802.3. Probably should blow that up a little bit so you can see it, but you can follow it as you're reading. Your assignment is going to be to read chapter 2, so you'll see all this. 802.3 is Ethernet. 802.5 is token ring. LLC was a sublayer of the data link layer. 802.11 is wireless. So these 3, 5, and 11 are the 3 most important ones here. It used to be 2. 802.2 was actually a frame type 2. So you got wireless PANs. Bluetooth is 15. The rest of them pretty much have dropped off, but 3, 5, and 11 are the 3 that are going to be the most important. One other thing that I want to look at is, if you keep going here, before we get to the questions, there are key terms. You can go through, there's ACK, there's CRC, There are some pretty good definitions in here. We'll come back to like ICANA and IANA. Come back to those later. There was a reason why. There's the three-way handshake, SYNAC, AC. There was a reason why I was going to bring you here. Because one of these definitions was a good one. The chapter summary here is actually pretty good too. So looking through the chapter summary is, especially later on, is a nice review. It goes through and basically hits all the main things. There was a reason why I panned back here, but for the life of me, I cannot remember what it was. But looking through this list is pretty good, and the things that we talked about a lot, you should probably make sure you know. Oh, I know what it was. Session layer. Yeah. Fifth layer establishes, maintains. That's not the best. It establishes, maintains, and terminates connections between PCs, or between nodes is actually a better definition. Anyway, there are some questions. You can do the questions. Yeah, let's do the questions. We'll do the questions. That'll be an assignment, and you can turn it in, and then I'll have some other questions that you'll have to answer. So your assignment is now going to be to read chapter 2 and kind of process all of this. So I'm actually more interested in this and you understanding how all the pieces and parts fit together than I am about the questions at the end of the book. So I don't know. When I get done and I get ready to post this, I'll have the homework. So whatever the homework says, go ahead and do. Whether I'm going to assign it or not, looking through the questions probably is a pretty good idea. And definitely one of your homework assignments is going to be to write all of this out so that you have it. This is also one of the things before the midterm, most people will write out and be able to dump and get all of this. Because if you can get all of this, you understand what all the parts and pieces are on the bottom 4 layers, and well, I mean, in the 7 layers, the top three are pretty cheesy. There's not a lot to them, but if you can get these bottom 4 layers and you get basically all of this loaded up in there, you've gone a long way to understanding all the parts and pieces that are in OSI. Okay. I think we probably have one more wrap up before we go on to the next section, but we made a lot of progress, and you just need to make sure that you understand this before we go on to the next section. All right, talk to you later.